Okay, so let's start. We only got one lesson. I will discuss with you the answer to the question in the makeup class later. Does everyone have your paper? Your paper, you can take somebody else's paper.
Guys.
Right. So I will discuss with you the paper in the makeup class today. We have got only one lesson. Okay. So we're gonna start. Okay. So last time we stopped at the Okay, last time we stopped here on the test for unsaturation in the molecule. And there are two ways we say that we can use to test for the unsaturation. One is by using bromine in organic solvent. Okay, the second way is to use potassium permanganate. But can you put down the condition for this chemical? This has to be cold and so this has to be cold, dilute, and alkaline, a solution. As you will learn later, okay, right. Yeah, you missing your paper is missing a page. Okay, so I will not. There should be a total. There should be a printing on each side. Yeah, don't worry. Yeah, I will not count this one for you. But we have a retest tomorrow. Let me remind you, we have a retest tomorrow. So I want all of you to come to the after school makeup class so I can explain this paper for you.
Sir, I have training.
Sir.
Huh?
Training.
Training. I'll record it. So you
Monday and Thursday.
I know some of you will not make
Tomorrow's
next.
Thursday.
Okay. Yeah, let's finish this later. I know some of you will not make it, which is why I will record the lesson. You have to watch it by today. As we have retest tomorrow. Tomorrow. We
Tomorrow.
have you got your test?
I'm confused.
Monday and Thursday. We have the retest tomorrow. So you have to come to the makeup class after school today, and I'll explain this paper. Yeah, so can everyone?
Is it tomorrow after school or during lunch?
It's I think we're planning tomorrow.
Yeah.
Yeah. So in that two lessons we have the retest. So retest. So okay, let's start. When we react cold, dilute, and alkaline, okay, you need to remember these conditions. Cold, dilute, and alkaline, KMnO4 with CC double bonds. Right, yeah. Can you return to your seat? Okay. It will form what we call a diol. Okay. So if you remember, so when you react CC double bonds with oxidizing agent, what does this square bracket O mean? Put that down. Square bracket O means. I will discuss with you the answer if you come to the makeup class tonight. Even if you cannot make it, I will record it. Make sure you watch it. There's no excuse for not attending the makeup class from this point onward. So oxidizing agent means, so this square bracket means the oxidizing agent KMnO4. So we write this in the equation. And if you count carefully, you can see that there is a total of 2H and 2O in just the oxidizing agent and the H2O alone. And these two O and H's, okay, they are equivalent to 2 OH group. So you have 2 OH group. They will then be added across the double bond, like that. So you have the OH here and the OH there. Okay, so you are adding 2 OH groups across the double bond. And on top, you're doing similar things. Yeah, here you add 2 of the same thing, they are Br. And here you add two of the same thing, they are OH, into the double bond. And this will result in a color change. A color change from purple to colorless. Okay, so this is purple and oxidizing agent. It will then become colorless. So in both cases, remember, the color change will be to colorless at the end. So can you put down the color change for when you use bromine water? When you use bromine, the color change will be from orange to colorless. If you use potassium permanganate, KMnO4, the color change will be from purple to colorless. And this color change will occur only when you have double bond in the molecule, only if you have CC double bond. So if CC double bond is or are present, yeah, there can be more than one double bond, then you will see the following color changes. Is that clear? Yeah, so when you add bromine into a substance and it stays orange, then you can conclude that it does not have CC double bond. Okay? But then there's a catch. You must make sure that you are doing this test in the absence of UV light. Why is that? Because in the presence of UV light, okay, even the alkane can react by substitution, right? Okay, so to help you see what I'm talking about here, I have three different substances. Yes. Right. Yeah, I didn't realize they are. Thank you. So if we have C3H6, if we have C2H4 in here, which of these will turn bromine water, will turn bromine from orange to colorless in the dark? In the dark. What do you think?
Double bond.
Only the one with double bond. But when you have sunlight around or UV light, so the UV light can cause the alkane to also react. So let me add a few drops of bromine water from on top. So in the lab, when we test if a substance has double bond, we need to make sure that we are doing it in the absence of UV light. Because the presence of UV light can cause alkane to react. So you see this is in darkness, okay? Yeah, so let me put this down here. When doing the bromine test, we should test for CC double bond. Yeah, the reaction must be carried out in the dark. So it must be carried out in the dark, meaning without UV light. Okay, so that is without UV light. Because alkanes, they can react with halogen in the presence of UV light. But of course, in the dark, there will be no reaction. Okay, so can you write down these two word equations for me? Alkane plus Br2, it will form, there will be a reaction. Yes. Yes, let me scroll down. Okay, so there will be a reaction. But when you mix the alkane and bromine in the absence of UV light, okay, so no UV light, then there will be no reaction. And then for alkene, it's different. Alkene, it will react with bromine no matter what, okay, with or without UV light. It just doesn't care, you can say. Or you can just assume that alkene, they are so reactive that with or without UV light, there will be a reaction always. Yeah, so always a reaction with or without UV. It will happen still. So this is why you want to do this experiment in the dark. Because if you do it in UV light, then I can tell you that you will not be able to tell them apart. They will both turn colorless. Okay? Yeah. I mean, if you do it in the sunlight, they will both turn colorless. But if you do it in broad daylight, like you see in here, what do you think will happen to the reaction mixture? Which one will turn colorless? Which one will stay orange? So in broad daylight, they will both turn colorless, right? Yeah, but in the dark, which one will remain orange? Alkane. Yeah, alkane will remain orange, and the right one it will turn colorless. Yeah, of course, color doesn't mean white, but yeah, I'm making it more clear in here. And below, they will both turn colorless in sunlight. This is why the test must be conducted in the dark. If you do it in bright daylight, you will still not be able to tell them apart. is actually the test for C double bond. Okay? So now we need to look at the other reactions of alkene. Does anyone remember the other reactions of alkene other than reaction with bromine and KMnO4? It can also react to form plastics. Do you know what plastics are? Some examples of plastics include polyethylene. Have you heard of PE before? Polyethylene. Polypropylene, yeah, maybe you've heard of polypropylene, or polystyrene, PS. No, never heard of it. Later when you buy takeaway lunchbox, look at the packaging. You will see symbols that look like this. And you will see letters like PE, PP, and PS. Okay, they stand for polyethylene, polypropylene, and polystyrene. They used to make different types of plastic objects, okay, which we'll look at next. So write down a new title here. Addition polymers. So what are addition polymers? So before we understand what addition polymers are, I want you all to look at this Lego block. So all of you should have played with like Lego blocks before. So you know I have a single Lego block here. What happens if I have hands of these Lego blocks stacked on top of one another? They can come together to form a much longer chain, right? So that, yeah, we can use this to understand addition polymer. Addition polymer is really formed by just stacking up many molecules of the same type together. And we have to learn two new words today, describing what is on the left, what is on the right. What is on the left, we call it the monomer. Okay, a monomer is kind of like one single Lego block. So what do you call a chain of Lego? We call it a polymer. And in this process, you know you're not dislodging or detaching anything from the structure. You're just adding things up. Nothing is removed. So we call this addition polymer. You highlight the fact that you're just adding things up, you're not removing anything. So this is analogous to a chain of Lego blocks. Okay, so the chain of Lego blocks. This process, we call this addition polymerization. The process of making such a long addition polymer, we call it addition polymerization. And we have to do n times here. Yeah, because in reality, when we combine monomers together, we don't just combine 1 or 2 or 10. We are combining tens of thousands of these monomers together. So, and because we don't bother counting how many there are, we just write n. Okay, and this is why you will see something like this. Okay, there, you see dot here, meaning that there are many Lego blocks to follow and many Lego blocks that come before it. This is why we put an n in here. Okay, so many monomers are involved. Okay, so sorry, so involved. For example, more than 4,000. So n is a very large number. So we don't have to know what that number is, it's just very large. So let's see how alkenes can combine, okay? Monomers, the addition, in the addition polymer chapter, okay, monomers are things with CC double bond. Okay, the monomers are alkene based, meaning they have CC double bond. So that means they have CC double bond. For example, these are some monomers. You can have C. Can anyone name this alkene for me? What is this alkene called? The name. Okay, the IUPAC name. You don't need a number this time because the double bond can only be placed between these two carbons. Is there another position where you can attach this double bond? No. Okay, so this is just ethene. Write everything in lowercase, please. And what about the next one? Okay, so hopefully you all know what the name is for this one. What about this? How many carbon are there? 3. What is the root for 3? Pro. Yeah, by this time you should have memorized what is on that worksheet I gave you. There will be a test coming up soon. Not just the test tomorrow, but also the test on organic chemistry when we are done with this chapter. Okay, so this is protein and we are about done. okay, with this chapter. And finally, just one more. What about this one? What is the root for 4? Build, I hear build, and then build 2 in. Build 2 in. Remember what the 2 describe? The 2 describe where the double bond starts. Yeah, where does the double bond start again? Carbon number 2. It doesn't matter which way you count. You can count from the left, you can count from the right. The double bond starts at carbon number 2. As such, this is called build 2 in. So whatever the alkene use, when you put a lot of these alkenes next to one another, an interesting reaction will happen when many alkenes come together. So when N alkene, so when I'll move it down a bit, sorry. When N alkenes polymerize, to form addition polymer, the following occurs. Okay, so remember the changes. So the following occurs. Number one, you will see that when you have N of these monomers around, it doesn't matter what these groups are, they will not react in the process. The whole thing, they will be turned into something that looks like this. Okay, so you have a bracket and then N on the outside. So what is happening is, for example, when I have ethene, so can you copy this 2 times? Copy this 2 times, and we'll draw 2 examples here. If the starting monomer is ethene, meaning it has 2 carbons and 4 H's, then the product will look like this. You see these groups, they remain unchanged in the process. These 4 H's, they are still there. Okay, the only change that happens, can you compare the diagram on the left and on the right? Tell me what is changed. Yes, double bond is changed to single bond. That's change number 1. You use a different highlighter for each change. So the first change is that the double bond will be converted into single bond. The second change is the number N here. You will suddenly see a number N shown at the bottom right hand corner of this bracket. You see a bracket. The third and the final thing is the inclusion of a bracket with a bond on the outside. Yeah, you see the bond, it cuts through the bracket. Okay, so the bond cuts through the bracket because this is just part of the structure. This is repeated N times. Okay, meaning you can have 4,000 of these connected next to one another, and there's no point drawing 4,000 of these. So instead, we'll just write N in here. So you can see that put down 3 changes to make. So 3 modifications. Okay, to make. Number 1, turn the CC double bond into CC single bond. The first thing you need to do. The second thing you need to do is to write N as a subscript outside a bracket. Yeah, and finally, point number 3 is to draw 2 new bonds sticking out from each side of the carbon. You can see this is one carbon, this is the other carbon of the double bond. You stick out a bond from each of the carbon to the in the outward direction. So draw 2 new bonds. Okay, next to each carbon in the previous CC double bond. Okay, which is now the CC single bond. So these are the 3 changes you need to make. So, and then actually there's just one more point. It's in the naming of the structure. What do we call this? We call this ethene, right? Do you remember? Yeah, this is ethene. So what do you call the product that gets formed? Well, it's conveniently named polyethene. So likewise, if you start with propene, which is a class exercise now, I want you to draw propene in here and show me what will happen to propene when we add them by addition polymerization. Yeah, show me the products on the right. You have draw it out, and then we'll check the answer. Okay, so you have CH3 in here. So one corner has a carbon. This is why you have 3 carbons, and therefore pro in the name of the compound here. E, so there are 2 carbons. You have 20 seconds to draw the product on the right. So this is called polyethylene. Don't forget a bracket, poly bracket ethene. We like to include ethene in the bracket because we want to let others know what the monomer was. So by looking at what is inside this bracket, we can find out what the monomer was. Okay. So let's check the answer after you're done drawing. So this general pattern on top you need to remember. Okay. So and remember this process we call it addition, polymerization. And don't forget that carbon can only form 4 bonds. So don't violate that rule. Okay. Because some students will draw a double bond in here and that would violate the rule, okay, of carbon forming 4 bonds. If you keep this as a double bond, it means each carbon is forming 5 bonds. This is prohibited, okay? So we'll have to make it a single bond. Yeah, you can also say this is an explanation on why the CC double bond has to be turned into a single bond. If you maintain the double bond nature of the CC double bond, you will violate that rule. Okay, this is why it has to become a CC single bond. Okay, so let's check the answer. We'll have H, and CH3. What is the name of this polymer? Poly bracket propene. Okay, yeah, I know you don't have to tell me the bracket in your answer, but write it in your answer. Polypropene. So that's the polymer. Now let's take the question up a notch. Okay, what about this one? So draw. You know in the exam they won't show you this structure already. They will just give you a condensed structure. I hope you still remember what condensed structural formula is. So this is one last question before we move on. So draw the polymer that can result from build 1 in. Okay, I know what I told you about earlier. I drew build 2 in. Can you draw build 1 in first? Yeah, so I'll give you all 20 seconds to draw build 1 in. Okay, we will break this down into several tasks. Task 1 is to draw build 1 in out. Don't need to draw hydrogen. Don't need to waste time drawing hydrogen, which is why I only gave you 20 seconds. Just show me the carbons and where the double bond is at. And that's it. So complete task 1 first. Draw build 1 in. So for those of you who have forgotten what these things mean, build means 4 carbon in the main chain. 1 in means the C double bond starts at carbon number 1. So with that being said, what is the structure like? So check your answer. C, 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 C. The double bond starts at carbon number 1. This is what it looks like. And can you put back the remaining bonds? Don't need to indicate hydrogen, but I want to put back how many bonds there are on each carbon. So for the first carbon, can anyone tell me how many hydrogen are there? 2, because carbon must form 4 bonds. So if it is involved in this relationship with another carbon, there must be 2 hydrogen left. What about the second carbon? How many hydrogen? Oh, it already is. Let's take a look. There's 1 bond, 2 bonds, 3 bonds already. Yeah, don't forget to count both sides. So how many left? 1. Just put 1 hydrogen. Don't put another thing in here. I still see this mistake in even the Form 6 student. This is bad. Okay, I want to correct this mistake right now. So what about the third and the fourth carbon? The third carbon should have 2, and finally 3. Yes, that's what you need to do. Okay, yeah, maybe draw the previous structure. Okay, because in exam I don't expect you to jump immediately to the answer, so you can show your thought process. You go from here to remembering that each carbon forms 4 bonds. So each carbon forms 4 bonds. That you know how many hydrogen there are. Next up, you need to draw it in this form. Does it look like the alphabet H to you? This? It looks like the alphabet, right? H. H. Okay? You need to show the CC double bond front and center now. So you see, we have a tendency to draw alkene in this form. Okay, I don't know what you call it, but to me it just looks like alphabet H. Let's draw this alkene in that form, shall we? So you have CC double bond. Yeah, this is the most important step. You need to put the CC double bond front and center. So let's do that now. You need to condense the other groups into like a single group. For example, if you put the CC double bond front and center, this is where it is. Can you tell me what should I write on the four corners respectively, given this structure?
CH2, CH3.
You mean this part, right?
Yes.
Yeah, this will be CH2, CH3. So why don't we do that first? So you have CH2, CH3. Can everyone see that this is CH3, CH2 first? Yes, we'll draw this here at this corner. So we'll put CH2, CH3. Make sure you write as CH2, CH3, not CH3, CH2, because is it the CH3 group that is closer or the CH2 group that is closer to the C? CH2. So make no mistake, it's not random. It's not randomly written. Yeah, you get me, right? Why shouldn't it be CH3, CH2? If I see that in your answer, I'll mark it as wrong. Okay, and then you have, what about the remaining group? They are all H's. Do we all agree that they are all H's? Okay, yeah, that's what you need to do. So put down 3 H's on the sides here. Yeah, and that's already the hardest task. Okay, the second task is to go from here, polymerize it. Okay, so draw the addition polymer. So can you do that now? By making the 3 modifications we discussed on top. So draw the addition polymer by doing the 3 modifications discussed. Okay, so 3 modifications. What are the 3 modifications again? Don't look at your notes, don't look at the screen.
Bracket.
You need to add a bracket. Number 1. What are the 2 other modifications? Change CC double bond into single. Finally, we add 2 bonds or lines on the sides of the carbon. So can you do that now? Don't look at your notes on the previous page. Just look at the monomer. I want to see the polymer now. So 3 modifications. So we have this, and then remember this is called addition polymerization. So addition, and you need to write things in full, yeah, in the exam. Addition polymerization, and right now n times you will have n of these, and then you will have something like this in the end. So show me the product, and then we'll move on. What is the n supposed to mean? It means there are many. There are so many that you lost count, or you just don't care. Okay, yeah, and we just don't care. Okay, I don't care. Okay, there are, like I said, more than 4,000. Sometimes in the million range. Okay, because it differs, so we simply not write it down. Let's check the answer. Okay, you have something on your booklet now. You have CH, CH, C2H5. Yeah, if you're feeling lazy, you might even condense it to C2H5, you know, so C2H5. But that's the most you can do. Okay, you can't be so lazy and then write something like this, like C4H8. No, this is too lazy. Okay, yeah, we don't do this. Okay, yeah, this is good. This is not. Is everything clear? Because next up, we will look at the different types of plastics. Like I said, when you look at the plastic packaging, you will see many different types of plastic in everyday life. We can't live without plastic. So on the next page, we look at some examples of addition polymers. Starting with the one that everybody should have at home is polyethylene. Yeah, it can be found in plastic bags. Or maybe plastic, you know, those party drinking cup, okay? The disposable one, I mean. So they are polyethylene, or just PE in short. So you have PE. Yeah, they are used to make plastic bag, okay? So put down the monomer and draw the polymer. Yeah, so for each of the addition polymer below, we will do this for each of them. So we have monomer, which is ethene. So you can put down ethene. And from the name, you know E means 2. E means, what is the general formula of alkene? That's a function group. CN, 2 N, and that's it. 2 to that anymore. If you say 2n plus 2, that is your king. This is your key with an E, okay, double line like that. You have CnH2n. So putting it all together, you have C2H4. Yes, C2H4. And let's draw it. We have C double bond, and we have the H's on the side. That means the polymer must therefore look like this. C, and then you just straighten up the arms, and then you have H, and don't forget to put.
Are you supposed to put anything on the other two bonds?
Oh, in here? No. Yeah, they stay, like they just hang out on the sides, okay, without connecting to anything. Yeah, but yeah, here you are. So you have this. And this is the E. Let me move this off to the side. We have the monomer on the left and the polymer on the right, and this is what ethene means. Okay, so we have this to be, you know, the whole thing you can call it a polymer. But if you just look at the thing inside the bracket, this is what the monomer is. Okay, and from the monomer you can determine the name, and then you can deduce the structure and then the polymer. That's polyethylene. What are some uses? Okay, let me introduce to you two types of polyethylene. There are two types of PE. One is called LDPE, or low density polyethylene. So LDPE, so low density polyethylene. Yeah, the other, maybe you guess it, is HDPE, okay? So high density polyethylene. And from the name, okay, so just put down, this is a plastic bag or food wrap. So they are very light, they are very soft, okay? So food wrap. And high density polyethylene, they are harder. They are used to make plastic stool, okay, like those chairs, plastic chair. So plastic chair, I mean you can't sit on plastic, but you can sit on plastic chair, okay? Yeah, you can, but you can't support your weight. Okay. So you have a drinking cup. Yeah, that's it. So please come to the makeup class later today, where I will discuss the answer. And last reminder, we test tomorrow. This is a reminder. I'm not asking you if you want to do it. You have to do it. This will be graded for real. Okay, the previous one, yeah, maybe I will just use it as practice, but tomorrow the test is real deal. Graded. Okay?
But $10 today.
I lost $10. See you after class.